Well, we have the relation between Ka and Kb, the equilibrium constant for acid and equilibrium constant for base. So, in the case of conjugate acid-base pair, in a simple manner, you can say NH4 positive and NH3, which is it is a acid and it is a base. So dissociation of this acid, so NH4, which is dissolved in water to form H3O positive and NH3, which is a base. Then this equation we have to apply the concept of equilibrium. For this equation, this chemical equation, we have to apply the concept of equilibrium. So Ka, dissociation constant for acid, which is equal to, that is no doubt, the concentration of product, that is H3O positive and NH3, divided by the concentration of NH4. We eliminate the concentration of H2O because concentration of solvent we do not consider here. Look for the dissociation constant. Look the equation, the dissociation constant for base, which is NH3, which is dissolved in water to form NH4 and OH. This dissociation of the base, we apply the concept of equilibrium, that is the dissociation constant for base, which is equal to the concentration of product, which is the concentration of NH4 positive into concentration of OH divided by NH3. This Kb is nothing but dissociation constant for base. In the presence of acid and base, we dissolve it into water. When acid you have to dissolve in water, then base you have to dissolve in water again. So at that time, the self-ionization of water which is also occur. The ionization which is gives H2O dissociate into OH and H3O positive. So this ionization, which is by using the concept of equilibrium, ionization of water, so Kw, which is equal to the concentration of OH ion, OH negative ion and H3O positive ion. So OH negative ion and H3O positive ion. So Kw, it is called ionic product of water. What we called Kw is the ionic product of water. Look, when relation between the Ka and Kb, when the reaction Ka and Kb is added, then the Ka into Kb, the value of Ka, which is H3O positive and into NH3 divided by NH4, which is the value of Ka. Then the value of Kb is NH4 positive into OH divided by NH3. So here NH4 is cancelled. Then this NH3 is cancelled. The remaining value of Ka into Kb, which is equal to H3O positive, then and OH negative, which is comes to Kw, and the Ka into Kb, which is equal to Kw, and the value of Kw is 1 into 10 raised to power minus 14. Hence the proof that Ka into Kb is equal to Kw, then which is equal to 1 into 10 raised to power minus 14. Hence the Ka into Kb is equal to K. So all this using the relation, so we can say the equilibrium constant for a net reaction. But we can say the equilibrium constant for net reaction is obtained. How we can obtain the equilibrium constant for net reaction? We obtain by after adding two or more reactions equal to the product of equilibrium constant for individual reaction is the product of equilibrium constant for individual reaction. So K net, which is equal to K1 into K2 into K3 up to a n times. So you can say in one line the equilibrium constant for net reaction is obtained by after adding the two or more reaction equal to the product of the equilibrium constant for the individual reaction. That's all.